When assessment starts, the areas to be assessed are divided up into different sections based on either circuit or map sheet. The assessors are handed paper maps, forms. They go out into the field, they complete the assessment, they mark up the paper forms, they may mark up the maps, and then they drive those back into the control center. They're placed onto the desk of somebody who then has to go and then collate that information, turn it into actual information for the people running the storm to determine what the damage is at any particular point in time. That approach has been very effective given the technology that actually works in the field. So there's no point deploying technology for technology's sake, because the guys who actually have to go out and do the work will revert back to the things that are going to work in a storm situation. They're not going to use technology that isn't streamlined and effective for them out in the field. So they've done the best that they can with the technologies that have been available. There are a number of issues caused by the manual approach and the paper data entry. The primary one is the time it takes for detailed information to pass back from the field back to the control center in order to make decisions about the storm. Decisions involving, should I involve mutual aid? What's going to be the restoration time? Where do I deploy crews? Where do I deploy vegetation management crews? All those decisions can be speeded up if the data from the field can be gathered effectively and quickly and transmitted back to the control center. The second portion of that is, if data is manual, there's always the element of errors that are created through illegibility, transcription errors, just the translation of a manual form of data into an electronic form to make decisions. What we've seen is a large number of new technologies, driven a lot by consumer-based technologies, become available that can now be utilized in the field effectively. Previously, people were taking office-based technologies, laptops, etc., taking them out into the field, hardening them, taking applications which were developed for use in the office, and then taking them out, giving them to the guys in the trucks. And this was a less than effective mode of operation because they weren't tuned to the rigors and situations that the people were in during a storm situation. I think it's because of the dramatic impact some of the recent storms have had, with Hurricane Sandy and other hurricanes that have been hitting the United States over the last 5 to 6 years. The time of restoration and the economic impact is so huge that it was seen that the utilities not only needed to be relied upon for their own innovation, but both needed to be pushed and to be provided with economic incentives in order to improve the storm restoration process and the grid hardening in order to minimize the impact of storms when they do actually hit. What we recommend is one of the first things to carry out is an audit of storm process. A lot of utilities have already done that, but with mergers and acquisitions taking place, there are a lot more larger utilities who have a variety of different storm restoration processes that need to be analyzed. And also the systems that are involved in storm restoration really need to be understood as to the roles they play, such as GISs, CISs, outage management systems, SCADA systems, dispatch systems. So step one in the process is to go and analyze what is taking place right now. what's good, what's bad, what's best practice, what systems are in place that actually are operating effectively, and then what are the gaps in terms of communication and the gaps in terms of streamlining your processes. And there are a number of technologies driven by the consumerization of IT that are now available and effective once integrated into the damage assessment process. So the rise of usable phones, tablets, phablets, which can actually be effectively used in storm situations, at night, during extreme weather, has meant that we can actually deploy those effectively out in the field. The increased wireless coverage and reliability and robustness means that there's more opportunity for direct communication and immediate communication back to the control center. The availability of new data sets from cloud-based vendors such as Google, providing weather information, traffic information. All this information can be used to more effectively direct assessment activities in the field. There's been a huge innovation in the geospatial industry. Traditional vendors have done an incredible job of creating enterprise repositories where a true representation of your network is held. One of the challenges the geospatial industry has always had is taking that information and passing that out to the 95% of users in a utility that really need that information in order to effectively do their jobs. And systems such as PostGIS, Leaflet, PhoneGap, many open source different types of technology are now being leveraged by vendors out there to remove the gap which traditional GISs have been suffering from. In our experience, where if you move from a manual map-based approach to damage assessment to an integrated electronic damage assessment, we've seen improvements in major storms, such as anything over 3-day storms, of between 20 to 25% reduction in storm restoration times.